So next we're going to do Gaussian elimination with back substitution, and we're going to be a little sloppy about how we're doing it. We're just going to put it in a matrix. And so you saw that we had to write x, y, and z a lot here. There was a lot of stuff to keep track of, and if there were more variables, then it would be a lot to write. So an augmented matrix kind of streamlines it, but it also kind of makes things a pain in the butt. So, but it puts a system to it too, like do this, then do that, then do that, and then you will definitely get an answer sort of thing. But it leaves less room for shortcuts and kind of, I don't know. It's not my favorite method of doing it, but it has its reasons. So I'm going to keep the first row the same. So R1 is going to stay put. They like to have a 1 in that first spot. So my goal right now is to make this guy a 0 and that guy a 0. Basically eliminating the x's, just like I did over here. So if I do -2, so I'm going to make my new row 2, I'm going to do -2 times row 1 plus row 2. So if I do -2 plus 2, that's 0, but I want the x, right? Then -2 minus 3 is -5, -2 plus 1 is -1, 8 minus 1 is 7. Alright, so we've got that. And now we're going to do the same thing for the y's. So R3 is going to become -3 times R1 plus R3. So you do, or negative, not -3, -4. Because if I do -4 times this plus that, it'll go away. So -4 plus 4 is 0, -4 plus 2 is -2, -4 minus 3 is -7, and 16 plus 33 is 49. And it's so easy to lose stuff and just check in. We are looking good. Alright, so now, at this point, some teachers and some some people say you need to get a 1 there, right? You need to get a 1 there and then do it again. And then you go to fraction land, and you go to fraction land pretty quick, and it kind of is terrible. But I'm not going to go to fraction land just yet. I'm going to do another video where I'll go there. I'm not going to do it now. So I need to make, my next goal is to make this guy a 0. I'm not going for the full Gauss-Jordan, I'm not going for both of them yet. I'm just going to make a lower triangular. So that's Gaussian elimination, just the last 3, just the bottom triangle. So I want to make that a 0, and instead of multiplying that by a fraction, maybe I'll just make a match. Maybe what I'll do is I'll take maybe I'll just make R2 become -2 times R2, and then I'll make R3 become 5 times R3, and that way I'd have 10 and 10, and then when I add them, they'll go away. So let's let that happen. So let's let the first guy just kind of chill. And I'm going to do -2 times this one, so this is 0, 10 to -14, and 5 times this one, so 0, -10, -35, and 5 times 49, 245. Alright, so now my R3 can become row 2 plus row 3, and they'll go away. Alright, so the top is staying put, and even the second row will keep the same, and then this one we'll just do 0 plus 0 is 0, that plus that is 0, 2 minus 35 is -33, minus 14 plus 245 is 231. Alright, and so now we will, we basically have, we know that -33z will equal to 31. So I'm going to go ahead and do row 3 is going to become basically row 3 divided by -33. So I'm going to have 0, 0, 1, and 231 divided by negative 33 is negative 7. And then this row I'm going to put back, I'm going to just reduce to row 2 divided by 2. So that's going to, no, divided by, oh sure, divided by 2. So I'm going to have 0, 5, 1, and negative 7, and then I'll just let the top chill. And so for Gaussian elimination, as soon as you get, actually, I don't even need to go to that last step actually, as soon as you get that, that part there, yank it out of the matrix, yank it out. And just do negative 33z equals 231, so z will be negative 7, and then put that back into that equation, which is basically saying 10y plus 2z is negative 14. So 10y plus 2z is negative 14. So 10y minus 14 is minus 14. So 10y is 0, so y is 0. And then put those two back into the original. So x plus y plus z is negative 4. So x plus 0 plus negative 7 is negative 4. So x is 3. And I get the same answers that I got when I did it before. And I meant to be making a lot more parallels as I went. Notice that negative 5, negative z, 7, negative 5, negative 1, 7 is that right there. And then the negative 2, negative 7, 49. Where is that? Negative 2, negative 7, 49 is right there. And then everything is the same. And it's supposed to be less writing, but it's still really not. Still really not. Frustrating, but kind of cool, I suppose. Alright, so the next video I'm going to do total Gauss-Jordan elimination. I'm going to go not just for these bottom 3 zeros, but I'm going to go for the top 3 zeros too. Alright, stay tuned.